The other interesting idea to regularize your network is just use Ensemble. Okay, so what does this mean? Because what you're doing is each time you're training your network, you are initializing your weights randomly. And you know that the loss function you have, it's not convex. So there could be like a lot of different minimas. And if you have different initialization of your networks, like when you do that like multiple times, which means that even if you train the same network multiple times, the final weights is going to be different because the initial weights was different, right? And if that is so, then what you can do is at the end, you can, let's say, train 10 different models and then come up with a way to like fuse those predictions. You can take average, or you can take, okay, the maximum number of predictions when, let's say, 5 of the network are saying it's a cat, then you say, okay, it's a cat. So there are different variations how you do that fusion. But the idea is making use of multiple networks. And again, these are not different networks, same networks. The only difference is the initial weights were different. Okay, so this is again, it acts as a very good regularizer, and it in most practical scenarios mean this is what it's used. So we don't just use single model, we use multiple models. Okay. Now another interesting thing is we initialize the weights randomly, and we want the value of the weights to be different. The reason is if all the weights are actually equal, so what will happen, your network will not train, because you can think about this like all the values in your filters are same, right? So if you have 100 different filters, all the filters are going to give you same output, right? So when you compute the gradient at the end after you have the loss, so the gradient will be same for all the weights, right? Because the initial values were same, the outputs were same, nothing will be different, and the gradient will not change. The gradient will be same for all the weights. And when you make the update, again, the values will be same. So the network will not train at all. Okay, that's just a small point. Okay, so that's what I said. I mean, you don't just train one, you can train multiple models and just combine like those scores together. That helps you avoid this overfitting, and it also improves the performance.